So today we're going to cover the first part of section 4.4, which deals with solving polynomial inequalities. And you've actually already done this back in chapter 3 when we were solving quadratic inequalities. We're going to do it in the exact same manner. Basically, we're going to look at two different methods we can use to solve polynomial inequalities. One is solving by graphing. This is, again, the method that we used in chapter 3 when it came to solving quadratic inequalities, and the rules are basically exactly the same. When we get our inequality in the form where one side of the inequality is 0, basically the inequality sign tells us what we're looking for on the graph. If we have a less than inequality sign, it means we're looking for the intervals of x values below the x-axis. If we have a greater than inequality sign, it means that we're looking for the intervals of x values above the x-axis. Personally, I wouldn't recommend solving polynomial inequalities by graphing, besides when you're directly already given the graph or it's very easy to get the graph. So here in example 1, you have the graph of the polynomial x minus 2 squared times x plus 1. So here you're directly given the graph and you're asked to use this graph to help you solve x minus 2 squared times x plus 1 is less than 0. So what I first do is make sure my inequality is in the correct format. You can see I already have 0 on one side, so it is in the right format. Then I look at the sign and see what it's asking me for. A less than sign indicates I want to know which x values are below the x-axis. So you can see the area in red shown on the graph is the only area of x values or interval of x values for which the graph is below the x-axis. And you can see this interval will extend all the way down and all the way across to x being equal to negative infinity, and it stops right where x equals negative 1. And I put a parentheses on negative 1 since I don't have an equal on my inequality sign. So that's how we can solve polynomial inequalities by graphing. Now the other method we're going to use to solve polynomial inequalities is solving them algebraically by making a table. And that table we're going to make is the exact same table we used in section 4.1 when we went through the analyzing process. So the directions for creating the table are listed here. But again, it's the exact same table that we made in the last section. So in order to make a table to kind of help me determine where is my graph above the x-axis, where is it below, I first make sure the inequality is in the proper form with a 0 on one side. Then I determine the zeros, the solutions, the x-intercepts, the roots, whatever you want to call them. I figure out the zeros of the function. Then I use those values to separate the number line into intervals. Then once I have my intervals, I choose a value in each interval to plug into the function to determine if that interval of the function is above or below the x-axis. Remember, if the y value is above the x-axis, if the y value is positive, that indicates the graph is above the x-axis. And if the y value is negative, that indicates that that interval is below the x-axis. So we're going to go through two examples of solving polynomial inequalities algebraically. So here in example 2, we're asked to solve the inequality x to the fourth is greater than x. Now first off, in order to solve this, I need to make sure it's in the proper form. So I subtract x from both sides to get x to the fourth minus x is greater than 0. Then, in order to set up my table, I need to find the roots or the solutions to x to the fourth minus x. So to find those, I set x to the fourth minus x equal to 0. I factor, and then I set each factor equal to 0. And that leads me to two solutions, x equals 0 and x equals 1. So finally, I use x equals 0 and x equals 1 to divide the number line into intervals. That leads me to the intervals negative infinity to 0, 0 to 1, and 1 to infinity. You can see in the test row in my table, I then chose a value in each interval to plug into the function x to the fourth minus x. Determine whether the y value is positive or negative, which indicated whether the interval of x values were above or below the x-axis. Then finally, once I knew which intervals were above and below, I looked back at my original inequality, and I can see x to the fourth minus x is greater than 0. That means I want to know which intervals are above the x-axis, since I have a greater than sign. So I look back in my table and I can see the two intervals above the x-axis are negative infinity to 0 and 1 to infinity. And I have parentheses on 0 and 1 since there is no equal on the inequality sign, and I take the union of them. So finally, example 3, we're going to solve x to the x squared times x plus 1 times x minus 4 is greater than or equal to 0. So first off, the inequality is already in the proper form, where one side of the inequality is 0. So my next step is to determine the roots of my function x squared times x plus 1 times x minus 4. And you can see I do that here by setting each factor equal to 0 and finding my roots are 0, -1, and 4. So I then use those x-intercepts to create my table and to divide my x values into intervals. I have -infinity to -1, -1 to 0, 0 to 4, and 4 to infinity. Then you can see in my test row I chose a value in each interval of x values to plug into the function. Based off the value I was given, I determined whether my interval of x values was above the x-axis or below. Then finally, to get my solution, I look back at my original inequality. I have a greater than or equal sign, meaning I want to know where my graph is above the x-axis. And you can see from the table that would be my first and last intervals, -infinity to -1 and 4 to infinity. And finally, for my solution, I put brackets on -1 and 4 since I do have an equal on my inequality sign. Now that's the solution to the inequality listed, but I just want to show you kind of the different combinations with this particular function that could occur if we had a different inequality sign. So if my inequality was x squared times x plus 1 times x minus 4 is less than or equal to 0, notice because there's an equal on the inequality sign, I would indicate the intervals below the x-axis but with brackets. But by putting a bracket on both sides of 0 and the two intervals below, it's redundant. So really, the most proper answer here would be to just combine those two intervals together to create one interval from -1 to 4. Also, if we had a less than sign without an equals, there would be two completely separate intervals. But if there were an equal on my less than sign, I have to combine to get just a single interval of x values. And that is all for today.